So next, let's start finding the expression for each torque due to each force exerted on the post. So we'll make a table for our torque. We're going to find the torque due to tension. We're going to find the torque due to the weight of the sine. We're going to find the torque due to the weight of the post, and we're going to find the torque due to the bolt. So those are the things we're going to find. We're going to write down expressions for. So let's deal with the torque due to the tension first. Let's ask what sine of that torque. So here's our post. We ask what does the tension do? The tension would tend to rotate it this way. That's a rotation in a counterclockwise direction. That would be a positive torque. So the torque due to the tension in the wire is positive. Now let's settle on a method for finding our torque. We can do any of the three methods. Let's choose to do the lever arm method. So let's say that torque is equal to the moment arm, R perpendicular, times the force. So the next thing we're going to need here is what is the moment arm related to our tension force? What is R perpendicular? So to find R perpendicular, we'll have to think about that diagram. Let's just redraw it down here. Sometimes it's better to redraw the diagrams than to mess up an existing diagram. So for the torque due to the tension, here's our post, here's our tension force, and remember we're always asking for our moment arm is what is the line connecting the pivot and the force, and it has to meet at a right angle. So we extend our line of our force. Let's put in the 30 degrees that we know. And our pivot to our force at a right angle would be this distance right here. Okay, so that hits the line of force at a right angle, and that couldn't happen anywhere else. So we're extending the line of force, then we're connecting the pivot to somewhere on that line so it connects at a right angle. So here's our R perpendicular. This is the length of the post. That was given as 2.5 meters. We see that R perpendicular is opposite the angle, so R perpendicular is the length of the post times sine of 30 degrees. So we can fill that in our table for our moment arm. So we have L, I'll just write it as L for right now, we can deal with numbers in a little bit. L times sine of 30 degrees or sine theta, whichever you prefer. And then the force we're working with here is the tension force. So then we'll write down what is our expression for the torque. So it's these things multiplied. So our torque is positive L times sine 30 degrees times the tension T. Next, let's do the torque due to the weight of the sine. So let's draw our post again. Let's draw the weight of the sine. There's the weight of the sine. So our moment arm this time is pretty easy. We want to connect this to this, and we want to hit at a right angle, so we'll just go straight across. So there's our R perpendicular this time. We don't have to do any geometry to figure this part out. It says the sine is hanging 0.5 meters from the end of a 2.5 meter long post. So the entire post is 2.5 meters. This distance is 0.5 meters. So this R perpendicular has to be 2 meters. So our R perpendicular is 2.0 meters. We didn't fill in the sine yet, so let's ask what does the weight do? The weight tends to push it down this way. That's a clockwise rotation, so that would be a negative torque. And what is the force due to the weight of the sine? That would be the weight of the sine or the mass of the sine times gravity. So remember here where we're doing our force table, that's the magnitude of the force. So we just want the size here. The sign of the force doesn't matter. We get the sign of our torque from looking at the rotation. So then our torque due to the weight of the sine is minus 2 meters times the mass of the sine times gravity. Next we'll do the torque due to the weight of the post. I think we can squeeze that one in on this diagram right here. So there's the weight of the post points down. Our perpendicular for this guy will go from the pivot to where the weight acts. That's at the middle of the post. So that would be halfway, L over 2, or 1.25 meters. So 1.25 meters here for the moment arm, the R perpendicular. We ask which way will the weight of the post swing it? Swings it clockwise, so that would be a negative torque. Then the force is equal to the weight, the magnitude of the weight, which is the mass of the post, times g. Then we'll write down our torque, which is those guys multiplied. Minus 1.25 times the mass of the post times g. The torque due to the bolt, let's do the sine first. We ask, what does the bolt do? Let's just look at this picture. It's right at the pivot. If we push right here, nothing happens. The bolt force doesn't tend to rotate it, so it doesn't have a sign, so we'll call that one not applicable. Our perpendicular is the distance between the force and the pivot. Well, the force is on top of the pivot, so that distance is 0. What is the force? Well, that's the bolt force. So then the torque is those things multiplied, which gives us 0. So now we've decided on an expression for each term of our torque. Our next step will be to apply Newton's second law that says the sum of the torques is 0.